later you register. So we will have quiz for CLO1 theoretical and then CLO2 for our application. Okay, I think we have done this last week. So just a review. Okay, basic sets, fuzzy set operations. So we have two fuzzy sets here. So A and B. Okay, so this is the membership function value. Okay, this is the U. Okay, same also the U, and then this is the membership value for this fuzzy sets B. And how do you perform an operation of one fuzzy set to another? So it's equality. Say we have one is equality A equal to B if and only if A equal to B, where U is members inside this universe or this course. Maybe temperature, height, okay, pressure, force, or voltage or currents. Okay, so this is the value inside it. All right. In this case here, if mu A and equal to mu B, meaning that the A and B is equal, they are the same set. Okay, the same fuzzy set. Okay. Where every member in here is equal. Okay, U1 until from let's say this is U1 is a UN. For every U, give you the value of mu A are the same with this mu B. So A and B are the same set. Okay, union. Okay, union when you use union, you actually taking the maximum between the two. Let's say here we have A and B. So we compare these two. For every U starting from here to here, okay, any point start and then end, I compare the U of A and B. So then you get the maximum. Okay, for the same U. Okay, so let's say here, for this point here, A has a value, right? This is mu A here, but mu B is 0 because mu B is here, and then up to here is 0 until here is 0. So mu B is 0, mu A is certain value, so get the maximum. So you get the mu A. So you compare every U until finish, okay, until the end point. Okay, and then you will get the result. Okay, and then the result sometimes you write in this form. Yeah, in this form. So this is U. U is 2, 3, 4, 5, 6, 7, 8. This is discrete. Okay, discrete. Okay, in this case here, just now it is it can be continuous. Too far. All right, too far. So this is, let's say this is continuous. Okay. So the maximum will be A. This one, because mu B is 0. And this part here, mu B is still 0, and here mu A is greater than mu B. So we take the maximum between the two. So the union of these two fuzzy set is like a McDonald, like a McDonald symbol M. Okay. So same goes to here intersection, but intersection take the minimum between the two. Right? This one take the maximum. This one take the minimum between the two. So you compare the mu A and mu B for the same mu. Okay, meaning the vertical line. Okay, so take the minimum. So in this case, the value is here. Okay, this is the minimum between the two. All right, I think that one is important. And this one is subset, complement. Okay, right. The complement is the reverse of A. Yeah? So this is the complement of A. Just reverse it, meaning that you compare these two, the value is always 1, the maximum, and just minus. Okay, it's, for example, mu A is 0.1, so mu A prime will be 1 minus 0.1, give you 0.9. Okay, 0.9. If mu A is 0, like here, so complement A will be 1 here. Okay, so you always compare vertically, vertically. Okay, because we use U. U is down here. So for every U, you get the complement of the A. All right, this one has been done last week. I think this one is power. Okay, you give power to the mu, not the x, and not the x or u, but the mu. Okay, the mu. You give power to the mu. Okay, the membership values. Right, concentration also the same. Concentrations. Okay, not the u. You just change the mu the mu, the membership values. Okay, this is dilations, intensifications. I think there's others, not here, not in this. Okay, later if I cannot find it, I will give you another versions. Okay. Okay, I think you have done this, discussed this last weekend. All right, so to go to the new one, okay, 2.3.3. This is some advanced fuzzy set operations. Okay, algebraic product. Okay. What is algebraic product? The algebraic product of two fuzzy sets A and B is the multiplication of the membership function which is given by. You just multiply. Okay, multiply. Algebraic product is multiply. So we have mu A multiply with mu B. Okay, so normal multiplication. Okay. Members in U is member in element in U small letter U is members in universe of this course. Okay. Number two is algebraic sum. Okay, algebraic sum of two fuzzy sets A and B is also known as probabilistic sum, and is given by the following expression. Okay, let's look at the symbol here. A as a plus and B, and then there's a head here. Okay, there's a head above the plus sign, so it means algebraic sum. Okay, so let's see here. Mu A, membership of A, plus with membership of B, minus membership of A multiply with membership of B. This one. Okay, so I can write like this also. Put it here. Okay, mu A plus mu B minus mu A dot B. Okay, it is the same. Okay, it is the same. So nothing. I think this one is given in the list of formula. Okay, so you just know how to use it. Okay, it's better you memorize it. Okay, but it's still so many formula to memorize. Some of you we put in the list of formula at the back of the exam question. All right, consider the fuzzy set A and B, where A is this, so we don't care about the X or the U, okay? And then this is B. Okay, A is X1, X2, X3, X4, X5. Okay, and then this is for B, X1, X2, X3, X4, X5 is 0. X5 exists, but it is 0. Okay. So first is algebraic product and then algebraic sum. Okay, can we try this? Okay. Wait there. Can you try first? Okay, to see your understanding of the explanation itself. I will write it on the whiteboard. Okay, see, A is what? A. Let's see. 0.2 x 0.4. Okay, I hope you have the screen. I changed to whiteboard screen. Well, hopefully you can see. You can see. All right. Okay. I write in the other form. In the other form. So you can write like this with plus. But you don't plus it. You don't plus it. It's just how we write it. Okay. X1 is 0.1. 0.3, 0.6. 0.3, 0.6. 0.4. 0.4. X4. X5 is 0 actually. X5. We want to have to compare this is the U, the X as it is now. We compare between these two. Okay. Okay, the algebraic product. Okay, what is the formula just now? This one is X, is equal to mu A, mu B. Mu A is X, mu B, X also. All right, so you will get is 0.2, 0.1. Okay. Two. Okay, the pair. Okay, and then okay, this is the pair over x1 plus 0.4, 0.3, x2, okay, 1, 0.6, x3, right? 0.3, 0.4, 4, here is, here you can write, or just put 0, because x5 for mu b is 0. Okay, and then the answer is 0.02, right? One is 0.12. Normal multiplication. You have to write, okay? Or if you want to write for 0, you can write it, or you don't have to write. So you can leave it as 0. Okay. Straightforward. This one. But algebraic sum a little different. Okay. Mu A plus B. Okay. Right. The symbol is different. So you found this in the question. in literature, so it is algebraic sum. Okay, how is the operations? Is mu A x plus mu B x minus, okay, you can just write this one, or just you can write this one. Okay. For the first one only, for the first one, which is x1, right? 0.2 plus 0.1 minus 0.2, 0.1. Okay. All right. Mu A plus mu B, which is 0.1, minus mu A multiplied with mu B. Okay. Let's see the original formula. Okay, mu A plus mu B minus mu A multiplied with mu B. Okay. Okay. Second one, mu A is 0.4 plus mu B is 0.3 minus 0.4 multiplied with mu B. This one is for x2. And so on. So this part here, you don't have to write. You can write it. You have to write it. The last one, which is 0.1 plus 0 minus 0.1 multiplied with 0, x5. Okay, x5. So it is possible that this part will be skipped by a student. That's why you have to write it, because you have to cover every x. Okay, so this case here x1 until x5. This one is x1 until x4. So you have to add, okay, to ensure it is same pair. Okay. So here is what is the value here?
0.28.
0.28. 0.28. And so on, and so on. And so on. All right, you can continue. Important is the mechanic of it. The summation and multiplication is normal, traditional one. Okay. All right, Fuzzy set operations. Okay, this is the properties of algebraic product and sum. Okay, A multiplied with U is A. Okay, and A algebraic sum with null set is A. So you can prove this, you try to prove it. This is identity. Okay, identity. Try it. Let's say a number. So A is odd number, for example, U is a number from 1 to 9. Okay, 1 to 9, for example. Okay, and then you prove it. Okay. Yes, Nick.
So, what's the domain of a null set? Can you remind me?
Null set is nothing.
Nothing. Okay.
Nothing. Zero,
0. How about U?
Yeah.
How
U
about
is
U?
can be any. For example, a number from 1 to 100.
All right.
So the member is, for example, you start from 1 until 100. Okay, this is the universe of this course, the maximum. Maybe A is a prime number, for example, or B is odd numbers. C maybe even number. Okay, example for numbers. So U can be any universe of this course, like just now it's numbers, maybe it can be voltage, current, pressure, temperature. We have a minimum and maximum. Okay, so fuzzy set A, maybe for temperature, fuzzy set A, maybe you can use cool, and B maybe medium, C maybe hot. So you define the C maybe from hot, you consider as 70 degree centigrade to 100 degrees centigrade. So the U maybe from 0 to 100. Okay. So you can say also U to negative numbers. It's up to the applications. But now set is 0. Set 0. So if you apply this to now set, you will get A. Okay, then you apply multiply A with now set, you give you now set 0. Okay, because now set is 0. So you multiply anything with 0, you get 0. Okay, and then it's missing here. Okay, something is here. Okay. A algebraic sum with U, you give you U. So this is different from this one. This one is multiply, you get A. This one, it give you U. It's like a union. It's like a union. It give you the whole, the whole set. Okay, this one is commutativity. You can interchange with the position of A and B, or B to A is equal. Okay, A, B, B, A. So the position is changed. In this here, it is applicable, but not all. Matrix is different. You will do matrix multiplication, it gives you a different answer. Okay, A algebraic sum with B is equal to you apply B algebraic sum with A. So this one also, commutative, interchange. This one is associativity. Okay, you can do find A multiply with B first. The same for this also for algebraic product sum. So this, as I said just now, you can try it. Okay, let's say use numbers from maybe from 1 to 20. You can cover A is a prime number, B is the even number, C is odd number. So you can apply and then you can see the result to prove it. Okay, to prove it. Is it really like this? Okay. And the last two is the De Morgan's theorem. The De Morgan's theorem. Okay, you multiply A with B, then you get the complement of A and complement of B. Then you do algebraic product of these two. You give the same answer. This one may be worth to try. Okay. Also this one. Okay. Let's see. Can you try using this value? Using this, right? So don't forget this one is x5 0 0. Okay, here is so there will be same number of pair, 5 pairs. Okay, can you try this De Morgan theorems? Okay, do this. A and B here means you just use the mu, the mu. Okay, don't change the x. Okay, x is constant. So you just multiply or sum the mu values. Okay, 0 0.2, 0 0.4, 1, 3, 0 0.3, and 0 0.1. Don't multiply the x1, x2. Okay, it stay. It stay. The value is stay. Okay, try now. There's some. Okay, let me share my screen. I think I hope you do it. And you have memory, muscle memory that you can memorize. So the question is to find this, right? This and this, right? Back to the question. I think you can refer to the question. Okay, which is A dot B complement is equal to A complement algebraic sum with B complement. This is the question. A dot B A complement plus algebraic sum B complement. Is it correct? Yeah. So you have to find A and B, this is A and B. Okay, this is the result. Okay, A times complement it, we need 1 minus 0.02 equals 0.98. So when you combine these two, give you 1. Okay, one value. Or if you sum these two values, we give you 1. Okay, this one is 0.4, 0.3, 0.12. Complement, which is 1 minus 0.12, give you 0.88. Okay, and here is 0.4, complement of this. And then this one 0.88, and 0, the complement is 1. Okay, so this is the first one. And the second one will be this one, actually. And here is something missing here. Other thing missing. Okay, first you have to get the A bar, which is complement of A, and then the complement of B separately. Okay, so this one is 0.2, so 0.2, 1 minus 0.2, you get 0.8. Okay, and then 0.6, 0, 1 here, right? So 0, and then 0.3, so 0.7, and 0.1 gives you 0.9, the complement of A. Same goes to B. This is the complement of B. So the x5 is now is 0, so you get 1 here. Okay, so you have to ensure it is complete pair x1 until x5. Okay, although in the question x1 is not given, so you just add it up. Okay, then after that you get this one. Okay, a complement, algebraic product, a sum with B complement. So this is the formula. Okay, just now we write like this, right? So just simplify using AB. Okay, instead of using this new A, X, so you just use A and B. Okay. And then I think you don't need to use this one. A is actually mu A over X. Okay, A is actually mu A over X. Okay, X can be X1, X2, X3, X4, and X5. All right, so okay, I did this now. Okay, and then which is here. So you can complete with the others. Ava is 0.8 plus 0.9 minus multiply with this 2. Okay, and so on and so on. Okay, so 0.8 plus 0.9 give you 1.7, right? And then you multiply 0.9 multiplied with 0.8, you got 0.72 minus plus 0.8 plus 0.9, give you 0.98. Okay, this one will give you 0.98. Okay, 0.98 for x1, which is okay. This one is x1. X1. If you can see the bottom one, okay, you can see it. So the first element is equal. So you write for the second element, third, fourth, and fifth one. Make sure all the results are the same. Okay, because it says this is the De Morgan theorem. A multiplied with B, okay, complement equal to a complement algebraic sum with B complement. This is equal. Okay, at least for the first one is equal. All right, you can find for the others, and then understand how I got these values here. And then you normally, when you answer this type of question, you have to do this steps. Okay, don't just to here. Okay, you straight to here without this step. If something wrong here, it's no mark for your working steps. At least start first. and then after you get this value here, then you bar it. Okay, get the complement. Okay, and same goes to here because here you have A complement, B complement. So find the A complement, the B complement first. Then you do this process. So I think you have about 3 steps. Okay, 1, 2, 3 to get these parts, and then you have 1, 2 to get the first parts. Okay, so you have mark for your working step. All right, so we take a break for 10 minutes. So continue at 11. Right? Isa. Welcome, Isa. We just got the end of the part 1. Okay. Okay, we take a break, Isa, for 10 minutes. We will continue at 11.
So the quiz will be on topic 1, right?
Quiz is chapter 1, chapter 1, theoretical. I answer A, B, C, A, B, C, D. Okay, 10 minutes for 10 minutes for 10 questions. 1 minute, 1 question. Okay.
Thank you.
Hmm. All right. Okay, we continue. Okay, before we go further, I want to show you one part that not in your slides, but it should be in the slide. I don't know why I got the version of notes that I have don't have this. Okay, hedges in fuzzy logic. I will share with you. Okay, hedges in fuzzy logic. A linguistic variable carries with it the concept of fuzzy set qualifiers called hedges. Okay, hedges are terms that modify the shape of fuzzy sets. They include adverbs such as very, somewhat, quite, more or less, and slightly. Okay, this is an extension to the one that you discussed before, which is power, concentration, dilation. Okay, I already put these notes in the WhatsApp group. Okay, you can download the PDF versions. Okay, this is a diagram here. We call it what membership functions. Membership functions. So for height, so this is a we call capital U, universe of this course start from 150 centimeter until 210 millimeter. So in between, you have many fuzzy sets, okay, to describe like very short, okay, average, tall, and very tall. So this is fuzzy variables, okay. All right, let's see. All right, the fuzzy variable is height, okay, and then this is the fuzzy value, okay, short, tall, average, very short, very tall. So 1 2 3 4 5 values, values, okay, like a variable speed, the value is 100 kilometer per hour, but there is one exact values. For fuzzy, the value can be just like this, short. This is the value. For what? For the variable named height, okay. For increased set, this is one value, normally one value, 100 meter per hour, 100 kilometer per hour, one value for speed. But for height, maybe 1 meter, 1.5 meter, one value only for one variables. Okay. For in this case here, this variable has many values, and one values can extend from 150 until 170 for short. And let's see, this is short. This is the membership functions, the trapezium. Okay, and this one is very short. Okay, curve one, and then straight. Okay, straight and then a curve like this. So it is defined as very short. Later we will see in the form of formula. Okay, this one is average triangle form membership function, and then we have tall here. Okay, and then we have very tall. Here, curve. Very tall. There is a formula that like the power for the previous discussion. They can modify the membership functions. Okay, this one is tall, right? It's a very tall, so the shape is modified already. Okay, here is the explanation. Okay, for example, a little. A little means the membership values you power to 1.3. Okay, the power of 1.3. So this is graphical representation, the shape of triangle, the original one, for example, and then after you apply the power 1.3, the shape change a little, like this. Okay, and then the slightly, okay, slightly 1.7, power of 1.7. Okay, so this is the graphical representation of power 1.7 for slightly. Okay, slightly. This is the original lines. Okay, if you have this line, the result will be like this. Okay, this one is a little. This one is slightly. This one should be more because this is very power of 2 square only. Okay, more curve. Okay, and then the last one is extremely. So a little, slightly, very, extremely. Extremely with power of 3. So more curvy. The curve is more compared to the previous 3. Okay, so normally you are asked to sketch the resultant membership function. Even maybe for this case given to you is a trapezium. So this one doesn't change. One power of anything is still one, but this part will change. Okay, so this is the original one. So very short, very or extremely or slightly, it depends. Okay, on the question. And this is continue. Very, very. So very, very is the power of 4. Okay, more or less just square. So this part is power, and this one is concentration part. Okay, concentration. The shape of the mobility function is slim and slim. Okay, becomes smaller, smaller and smaller. Okay, this one is smallest. Okay, it's power of 4. This one is power of 3. So this one is a little, slightly 1.7, very power of 2, extremely power of 3, and then a very, very power of 4. So this part here is for square root. Square root. Okay, so more or less and somewhat is the same. Okay, square root 2. Okay, and then indeed a little different. Okay, if mu a is from 0 to 0.5, use this formula here. The power of 2 times 2. So it's slim. When the power of something here more than 1, so it is slim. Becomes smaller. Okay, compared to this one is dilation. Become bigger. Okay, wider. Wider. All right, for the value after 0.5 till 1, 0.5 greater than 0.5 until 1, this is the formula for indeed. So it is like complement, like complement of this. Okay, so it's become bigger. Okay, become bigger. All right. So you can go through later. This one for we call it hedges. Hedges. Okay. To modify the shape of fuzzy set. To modify the shape of fuzzy sets. Don't worry about the group naming. For the group naming, I will standardize it. I will standardize it. So you have 8 groups. So G1 until G8. Okay. Don't worry about the naming. All right. Share with you the screen. Okay, Alexander. So we have 4 groups now, 4 groups. Just put the name of the group, Anderson. Sorry, Alexander. Okay, we have just discussed about this. Okay, the Morgan's law. I hope you try the others. Okay. Yeah, I try only one. This part here, and then one part of it only for x1 only. So there is x2, x3, x4, and x5. So make sure the value of for every x is equal for both sides. Okay, if you do this, you get the result. You will get the result x1, x2, x3, x4, and x5, and you do this also, and then you get the result for x1 until x5. So make sure the pair is identical. Okay, like just now I have 0.98 for x1. So x2, make sure the same also. Okay, x2 is 0.88. Okay, for A product with B, and then complement. Okay, 0.88. Right, so the next one, fuzzy set operation. Next one is bounded product. Bounded product. Right, the bounded product of two fuzzy set A and B with membership functions mu A and mu B is the fuzzy set whose membership function is given by, okay, this is the how we write it. So differentiate with the product just now, which is A dot B. A dot B. Wait, where is it? A dot B, here the dot. So this is the algebraic product. Okay, this one is bounded product. So A B, just A B. Okay, then the formula is maximum between this. You have two value here. One is 0, one is mu A plus mu B minus 1. What does it mean? Maximum between the two. So the value here, the resultant will be at least 0. But there will no negative number. If there is negative, then we choose the maximum, which is 0. Okay, which is 0. So if you mu A plus mu B, for example, here mu A is 0.1, mu B is 0.1, 0.2 minus 1 is negative number, right? Negative 0.8, right? Negative 0.8. So the maximum between 0 and negative 0.8 will be 0. So there will be no negative number in this process. This is the reason. And to make sure that the result always at least 0. Okay, at least 0. And for the case, for example, here mu A is 0.5 and mu B is 0.6. Okay, so 0.5 plus 0.6 is 1.1, minus 1 will be 0.1. So maximum will be 0.1. So the output will be 0.1. Okay, so for every value below 0 will be set to 0. Okay, the second one is a bounded sum. Okay, bounded sum, this is the symbol A, and then you have a plus inside a circle. Okay, B. So this is called a bounded sum. Okay, the minimum 1 between 1 and this formula. So what does it mean? The minimum, so there will be no value above 1. In this case here, there is no value above 1. For example, you get value 0.8, mu B is 0.8. Combine, sum it, you get 1.6, right? So between 1 and 1.6, take the minimum, so 1. So always 1, okay, if you got the value above 1. So just want to make sure the result will always not more than 1. Okay, this one not less than 0. This one to cap it. So you plus mu A and mu B never exceed 1. Okay. In this case, and mu A and mu B is a positive number. Positive number. It's no negative number. Okay, it is a positive number. All right. So it's the meaning of bounded product. Azizan. Baru masuk ke Azizan? Itu tak apa, I don't record this one. You come late, then you miss the first part. Okay, this one, the third one is drastic product. What is after this exercise? Okay, drastic products. The drastic product of two fuzzy set A and B with membership function mu A and mu B if the fuzzy set whose membership function is given by these conditions. So we have three conditions. Okay, this is the symbol, the multiply sign in a circle. Okay, drastic product. A plus sign in a circle if you bounded sum. Okay, all right. Drastic product of A and B give you mu A. Okay, for mu B equal to 1. If mu B is 1, then the output will be copy mu A. Okay, in this case, if mu B is 1, the output just copy mu A, whatever value of mu A, for every U. Okay, in this case, for mu A equal to 1, just copy mu B. So this is like a reverse of this. Okay. Okay. And put it 0 if mu A and mu B less than 1. Okay, is it okay? If mu A is less than 1 and mu B is less than 1, put 0. How do we have the example for this? Okay, I understand. All right, for this case here, if mu A, for example, 0.8 and mu B is 0.8 also, just put 0. Okay, if mu B is 1 and mu A is 0.1, the output is 0.1. Okay, and in other case, if mu A is 1 and mu B is 0.5, so you just copy mu B. The condition is here. Okay, but if both mu A and mu B less than 1, so put 0. Okay, like let's see, the one that's one good, not good. The example is not good. All right, never mind. We do this exercise. Okay, consider the fuzzy set A and B, where A is given like this, x1 until x5, and then B is like this, x1 or until x5 also. Perform the following A and B on A and B. 1, 2, 3, 4, 5. Okay, I think we have done A and B, right? 1 and 2, right? Algebraic product, and we also have done the algebraic sum. Okay, so now why don't we try for 3, bounded product? Okay, bounded product, and then number 4, bounded sum, and number 5, drastic product. Okay, let's try. So we stop here today, this part here, before we continue to the second chapter, and then the third chapter, chapter 2, part 2. Okay, until we do exercise. Okay, it's better. Okay, let's say we do this. Number 3, 4, and 5. So we do with number 3, 4, and 5. Okay, while you do that, I also do on the whiteboard. Okay, and then for B, let's say we change it to 0.1. This one, let's say put it as 1. Okay, put it as 1. Okay, bounded product. Okay, the first one is bounded product. Bounded. Okay, Alexander Group. You should have 4. Okay, Alexander, Muhammad Hamizan, and then Muhammad Hazik. So plus one more. Plus one more. Right, drastic products. Okay, this is the for drastic product. And unquestioned for, sorry, we start from bounded product. Bounded product is this. Okay, mu AB. Okay, so AB, the bounded product is AB. AB like this. Okay.
Excuse me, Doctor. Are you, are
Yeah,
you
Nick.
sharing your whiteboard or?
No. Later we show. You do it
Okay.
on your own. Okay. You do on your own first.
Okay, sir.
Okay, everyone, do it. Try to practice your muscle memory. Okay. But we discuss with using this formula here. So maximum between 0 and mu A plus mu B minus 1. So you have to get the value of this mu A and mu plus mu B minus 1 for every x. X1, X2, X3 until X5. Okay. So in this formula, use U. Okay. X and U is the same. So I think someone has done it. So let's see. Right, for the first one, x1, we compare these two. So we have the formula for bounded product is maximum between 0 and this. Okay, which is this is mu b, kebetulan this is mu b. So mu a for x1 is 0.2 and then mu b for x1 is 0. Combine it minus 1. So you get 0, 0.2 plus 0 minus 1. It's negative number, right? Maximum. So you take 0. Alright, this is how we do it. You do this, then you did the formula in the note just now for x1, and then you simplify it. Okay, this is the result, which is we take the maximum, which is 0. This is negative 0.8. Right. So for the second one, you can do this as separately. For example, for x1, you do the process. Okay, which is how do you write it just now? Look at the notes back. And the formula 0 mu a x1 mu b x1 minus 1. So you do it one by one, x1, x2, x3, and then x5. Also k. Save it. That one is safer because if you do some mistake here when you copy the values, you don't get 0. Compared to you write this and then straight to here, something you get the wrong answer. Then no way I can give you marks because you don't write the steps. It's why important to write the step. At least maybe here and to here, be here, here and to here. And I know you know how to write the formula and know what to do. And only you mistakenly copy the values. Okay, maybe here 0.2 equals 0.5. Okay, maybe. So you can do this way one by one, or you just do like this. Okay. Okay, how about this one? This one is mu a x2, which is 0.3. So maximum 0.3, and then this one is 0.0 also. Okay, which is maximum 0 and 0.6 minus 1 is. So here is 0. Okay, 0 because it's negative 0.4. So we take the maximum, which is 0. Right, and then you continue for x3, x4, and x5. Okay. Maybe from here, just to save your time, and go to here and here. So you can skip this part. Okay. Sometimes you write slowly. So you have to at least you show the main formula, and then this formula here, only here. So this part here you can skip straight to here. Okay, straight to here, then the answer. Okay, you write this one and this one. Okay, you can skip this one and skip this one because it's here already written. You know the formula already. So you have to copy the formula for 5 times. Okay, only write one time here and then you just write this part here. Okay, and then set the answer. So you skip the certain no, steps because time in the test or in the exam, you are given time to complete the task. All right, I hope you know how to solve it. Okay, for the bounded product. Uh, how about the bounded sum? Okay, now we try bounded sum. Okay, hope you have copied the screen. Okay, I want to crop it off. Okay, print screen or use a snipping tool. Okay, let's go to the second one. The second one is bounded sum. Okay, the bounded sum of the same fuzzy sets A and B. Okay, what is bounded sum? This one, eh? Okay, let's see. While you do the question, I will write on the whiteboard. Sum. Alright, I think you already finished. So I show my screen. Right, this is another way to write the answer. Okay, the bounded sum. This is the formula. You write the formula one time. Okay, it's not given. It's not given in the answer paper. Sorry, in the question paper. Normally we give you a list of formula. Okay, if not given, then you write it here. Right, then you write for x1, x2, x3, x4, and x5. Okay. So the mu membership value for A bounded sum B for x1 is minimum 1, and then mu A plus mu B. So mu A is 0.2, mu B is 0. So you plus it here, you get, and then you get 1, 0.2. So choose the minimum, which is 0.2. Okay. Choose the minimum between 1 and 0.2. So you get the minimum is 0.2. X2 is part here. So we get the minimum between 1 and 0.3 plus 0.3, which is 1 and 0.6. So the minimum is 0.6. Okay, between these two numbers. Right, the third one, okay, x3, the minimum between 1 and 1 plus 0.6, which is 1 and 1.6. So now we choose this one. If 1.6 is higher than 1. So you can see the value of mu A bounded sum B is always 1 and below. Okay, 1 and below. Okay, this one is minimum 1 and here, right? 0.5 plus 0.7, which is 1.2. One. This one is mu A bonus sum, mu A bonus sum B for x5 is equal to minimum 1 and 0.1 plus 1. Curly bracket actually. We use curly bracket. Yes, curly bracket. Okay, curly bracket. Right, so you can see the membership function also changed. Okay, become maybe here. Okay, here. Okay, 6, 0.2, 1 here. Okay, this is x1, x2, x3, x4, and x5. Right, just continue going down here. Okay, for example. Okay, all right. So this is the answer for the bounded sum question. Right, so we use curly bracket, not normal bracket, parenthesis. Okay, you also can answer the question like this. This one nothing much easier, much easier. Okay, so the formula you just write one time, and then just fill, the substitute the values. Okay. Okay, the last one. The last one. This one I want to see the result. Okay, drastic product. Okay, drastic product. So using the same fuzzy set A and B. Okay, then now I'll give you. We have 6 minutes. Okay, 6 minutes. I will call someone to give for x1, x2, x3, x4, and x5. Okay, randomly. Okay, can you do it now?
Excuse me, sir.
Yeah.
What if mu A is equals to 5?
Where?
Katakanlah mu A is 5, mu B is 1. What's the output?
5.
Is it possible?
No, not possible. Maximum is 1.
Okay.
Maximum is 1.
Wait, what if both is 1?
So membership values is always between 0 and 1, including both. So there's no 1.1, 1.2, or 3, 4, 5. Okay, the membership value, we set it to maximum 1.0.
So what if mu A is 1, mu B is 1? Dua-dua 1. What's the output?
What do you think? All right, let's see this line here. You said just now, mu A is 1, mu B is 1. Okay, so both are correct, right?
Yes.
Both are 1. So the answer is 1.
Oh.
Okay, so you can use this one, or can use this one. Both are the same, you use the same answer. Okay.
All right. Thank you so much, Doctor.
Okay, I will show you my screen. We have no time. Okay. My whiteboard actually. Okay. All right, this is the formula, and then we try one by one. So x1, the mu A is 0.2 and mu B is 0, right? Mu A is 0.2, mu B is 0 for x1. So the mu A dot product B give you 0. Why? Because both are less than 1. Both less than 1, just put 0. Okay, that's why I put 0 here. Okay, for the second one, also the same, 0.3 and 0.3. So both are less than 1. Both less than 1. So just put 0. Okay, for the third one, x3, mu A is 1, mu B is 0.6. So it's fulfill this one. Mu A is 1. So we just copy mu B. So the answer is mu B, 0.6. Okay, and then x4, this one here. So mu A is 0.5. Mu B x4 is 0.7. So mu A cross product with B at x4 is equal to 0. Okay, because both are less than 1. The last one, x5, mu A x5 is 0.1. And mu B at x5 put 1. Okay, I change this part from 0.9 to 1. So the mu A B for x5 give you 0.1 because now mu B is 1. So we follow this one. The first one, mu B is 1. So the output of this, just take the value of mu A. Take the value of mu A. Okay. So this is the output. Okay, this is the output. Okay, 0, 0, 0.6, 0, 1, 0.1. All right. If both mu A and mu B is 1, then the output is 1. Okay, the output is 1. All right. Okay. Okay, see you next Thursday. Prepare for the quiz, CL1, just theoretical. The first chapter. Okay, guys. Sekejap je. Okay.
Okay.
Alright, okay. Assalamualaikum and good day.
Waalaikumsalam, sir. Have a great day.
Thank you.
Hello, sir. Hello.
Ya, macam mana?
Hold on. Yes, hello, sir. Sir, you saw my text on WhatsApp.
Ya, tapi I take time to answer. Sebab saya nak baca dulu kan.
Tu ID yang kita orang nak pakai.
Okay.
Boleh ke tak?
Boleh, better you nanti saya bagi macam satu format. You can write the proposal. You write in the program background, so I can read it in detail lah. What do you mean?
Tak boleh macam
The idea of the game is okay lah. Boleh lah. Tapi ni
boleh.
in detail nanti lah. Write in detail your proposal. Okay. All of you di proposal antara minggu ke-6 before the break.
Got it, sir. Thank you very much, sir.
Alright.
Sir, Mr. Can don't mind if you can record the class, sir. Because sometimes the internet not so good.
Okay. I try to record. Especially when I discuss the way the content.
All classes, sir. All classes, sir. Tak kisah, tak payah edit pun. Just like that, just put online only. Then at least all us can refer.
Yalah, itu saya baca teks je. Only when I do something like today, maybe memang saya patutnya lah record. Working ada kerja-kerja mengira lah kan. Tapi yang baca teks tu tak payah record lah.
Kalau boleh lah.
Ulang je kan baca ni.
No lah, it's not too much trouble. So just upload je lah. Kalau you can. So that we know that you don't really miss anything,
Alright, okay.
Thank you very much, sir.
Okay. Good day.
Day to you.